Hi guys, so Exams Vidhai is a non-profit initiative by the students of IIITDM Kancheepuram, and today we are going to be talking about trigonometry. So the contents of this chapter will be triangles, revising some basic terms, properties, some relations, defining some terms, formulae and some applications and problems. So let us jump into the chapter. So what is the definition of a triangle? So a triangle is a figure enclosed by three straight line segments, and the three straight line segments meet at three different points. And now let us revise some basic terms. So given here is a triangle ABC. So now a side is the line segment that forms the triangle. So here AB, BC and CA are three sides of the given triangle. Angle, the shape formed when any two sides meet is called an angle. So here ACB, CBA and BAC are three angles of this triangle. And vertex or corner, the point at which any two sides meet is called a vertex or corner. So here A, B, C are three vertices of this triangle. And note, every triangle will have three sides, three vertices and three angles. So if any shape doesn't satisfy these conditions, then it's not a triangle. So now here we have been given a triangle ABC, and based on its sides we divide it into three categories: equilateral when AB equal to BC equal to CA, and isosceles when AB equal to BC but not equal to CA, and scalene when AB not equal to BC not equal to CA. And based on angles, it's again divided into three categories: acute angle when all the angles are less than 90 degrees, right angle when only one angle is 90 degrees, and obtuse angle when one angle is greater than 90 degrees. So now let us discuss some properties of triangles which you might have studied in your previous classes. So in a triangle, the sum of all angles equal to 180 degrees. Now this is a famous property which you have studied. And in an equilateral triangle, all the sides are equal and all angles are equal to 60 degrees. Now this is a property, standard property of an equilateral triangle. And in isosceles triangle, the angle opposite to equal sides are equal. Now this is again a standard property of isosceles triangles. The angles of an isosceles right angle triangle are 45, 45 and 90 degrees. Now this is an inference from the previous point. And if ABC is a right angle triangle, then AB squared plus BC squared equal to AC squared. AB squared plus BC squared equal to AC squared. Now this is Pythagoras theorem, which is a famous theorem, and we will be using this extensively in this chapter. And for this chapter we'll be dealing with right angle triangles like the one here, and we'll discuss its various properties right now. And before that we'll do some relations. So here we have a right angle triangle ABC, right angled at B. Now let us consider the angle BAC first. So for the angle BAC, we have the opposite side as BC. The angle BAC, we have the side opposite to this angle as BC, and the adjacent side is AB. For this angle, AC is also adjacent. So but we have a separate name for AC known as the hypotenuse. So for any right angle triangle, the side opposite to 90 degrees is hypotenuse. So apart from hypotenuse, what is the adjacent side for this angle? It is AB. So now I have a question for you. So for BCA, what will be the opposite and adjacent sides? So for BCA, so for this angle, the opposite side will be AB and adjacent side will be BC, right? Okay, so now we'll be defining some terms right now, so pay a little bit attention to here. So here for any angle theta, we say sine theta, or abbreviated as sine, opposite side by hypotenuse. And cosecant theta, abbreviated as CSC or cosec, is reciprocal of sine. It is hypotenuse by opposite side. And cosine theta or cos theta, adjacent side by hypotenuse. Secant theta or sec theta, it is reciprocal of cos and it is hypotenuse by adjacent side. And tangent or tan theta, which is sine by cos, is opposite by adjacent. And cotangent, reciprocal of tan, which is adjacent by opposite. So now here we have a triangle ABC, and for theta, which is BAC, we have opposite as BC and hypotenuse as AC. So sine theta is BC by AC and cos theta is AB by AC, right? And tan theta is BC by AB. Now for remembering all these ratios will sometimes be difficult for you. So I have a trick for you so that you easily remember and solve problems. So for remembering sine, cos and tan ratios, use this bolded underlined letters trick. It is SOHCAHTOA. I'll give you the expansion. So S stands for sine, C stands for cos, and T stands for tan. And O is opposite side, A is adjacent side, and H is hypotenuse. Now, what is the full form? Sine is opposite by hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. So now with this you can get the ratios very easily. Instead of memorizing or by hearting all these things, just remember this ratio or write it beside your problem and your problem will become very simple. And again, so remembering the reciprocal of sine or reciprocal of cosine or reciprocal of tangent might be sometimes difficult. So for that I have a trick. So if S comes first, then reciprocal starts with a C, and if the ratio starts with a C, then reciprocal starts with a S. Now I'll give you an example. So let us say we have sine. Now we need to find the reciprocal of sine. So the reciprocal of, we have an S here, so reciprocal should start with a C, right? So, but we do know for sure that it is not cosine, because we have it here like sine opposite hypotenuse, cosine adjacent over hypotenuse. So we know it's not cosine. So what is the only ratio which starts with a C? We have cosecant, right? And the exception is for tangent and cotangent. You can just directly remember this. Now if you want the reciprocal of secant, let's say reciprocal of secant is cos, we know, right? So for it starts with an S, so secant, the reciprocal should start with a C, and we know it's not cosecant, so it should be cosine. So you can remember these reciprocals and the ratios very easily with these two tricks. Now let us try to calculate the sine, cos and tan of some angles. So here we have an isosceles right angle triangle, right angled at B, as you can see 45, 45, 90. So now we know from the properties of isosceles triangles that if angle BAC is equal to angle BCA, then AB equal to BC, right? So then from Pythagoras theorem, now before this step, let us assume the side AB equal to BC equal to X. So from Pythagoras theorem, we know AB squared plus BC squared equal to AC squared. So X squared plus X squared is equal to AC squared. So AC is equal to root 2X. So for angle BAC, so here BAC equal to BCA, so we can calculate the ratio for any angle. So let us say we take angle BAC. So what will be the opposite side? BC. What will be the hypotenuse? AC. So X by root 2X. What is opposite over hypotenuse? So SOH. So sine. So sine of 45 is 1 by root 2. And cosecant, if it is starting with an S, then the reciprocal should start with a C. So cosecant, which is 1 by root 2, which is root 2. And same you can do for cosine at AB by AC, which is 1 by root 2. And secant, C, then S. So it should be root 2. And tangent, which is opposite over adjacent, TOA, TOA, opposite over adjacent. So 1 by 1, which is just 1, and cot is in reciprocal cotangent. So 1 by tan, which is 1. Now let us calculate for a triangle with 30, 60, 90 measures. So here we have a triangle 30, 60, 90. So now there are many ways of calculating the ratios for these two angles, but I'll give you one simple way, one easy way of doing it. So let us first assume that the side opposite to 30 degrees as X. Okay, so far so good. Okay, so now, and we assume the side opposite to 90 degrees as 2X. So first, what is the first step? The side opposite to 30 degrees as X and the side opposite to 90 degrees as 2X. Now we know two sides. You can get the third side by Pythagoras theorem, which is root 3X, right? So 4X squared minus X squared root, which will be root 3X. Now it's very simple. You know the side measures in terms of X. You just need the ratio. So you just, let us first take the angle BAC. So for angle BAC, you get sine 60, which is root 3x by 2x, opposite by hypotenuse. So root 3 by 2. And the cosecant, which will be reciprocal of sine, which will be 2 by root 3. Next, cos 60 is AB by AC, adjacent by hypotenuse. So x by 2x, which is 1 by 2. And secant reciprocal of cos, it is 2. and tan 60 is opposite over adjacent over, and root 3x by x, which is root 3, and cot, which is reciprocal of tan, which will be 1 by root 3. Now we'll calculate it for 30 degrees. So here we have the same triangle. So 30 degrees. So for 30 degrees, sine 30 opposite over hypotenuse SOH. So x by 2x, which is 1 by 2, and cosecant, which is reciprocal of sine, which will be 2, and cos is adjacent CAH, so adjacent by hypotenuse root 3 by 2, and secant, which is reciprocal, which is 2 by root 3, and tan, which is 1 by root 3, and cot, which is root 3. So now this is something which you need to understand. So now ratios of 0 degrees and 90 degrees. So not everywhere you'll get angles such as 30, 60 or 45. You might get angles of 0 degrees and 90 degrees. So how do you do that? So now for this you need to visualize from this figure. So now let us say this 30 degrees gets to 0 degrees. So if this 30 gets to 0, then this A point coincides with this B point. So this point coincides with this point. Okay. So if that's the case, then what will be the opposite side? Opposite side will be AB, which is 0 here, right? So opposite side will be 0, and hypotenuse, it doesn't matter. So hypotenuse, anyway, whatever be the hypotenuse, your opposite side is 0. So numerator is 0. So your sine 0 will be opposite by hypotenuse, which is 0. So sine 0 equal to 0. That's what I've written here, sine 0 equal to 0. Now for cos for this angle, now let us assume this is 0. So BC is your adjacent side, and your BC equal to AC, because this AC coincides with this BC, right? So your adjacent side and your hypotenuse are equal. So what is cos? Cos is adjacent by hypotenuse, both are equal. So your cos 0 ratio will be 1, and tan 0, which is sine 0 by cos 0, which is 0 by 1, is equal to 0. Now let us do for 90 degrees. Now for 90, you need to again visualize over here. So for 90, the opposite side is again hypotenuse. The hypotenuse is going to be the hypotenuse. So AC equal to AC. So your sine will be opposite by hypotenuse. Both are the same for 90 degrees. So it will be 1. So sine 90 will be equal to 1. Now for cos, for 90 degrees, there is, you just visualize over here, for 90 degrees you don't have any adjacent side, you just have only opposite side, you don't have an adjacent side. So for here, so cos 90 will be adjacent by hypotenuse. So for adjacent, there is 0, and hypotenuse is 2x, but it doesn't matter, so 0. And tan 90 is sine 90 by cos 90. Now 1 by 0 is not defined, so we say tan 90 is 1 by 0, and it is not defined. Now to sum up, we have this table. So here you can remember this table, or you can even prove it on spot, it's your wish, but I would say you should prove it on spot, but you can even remember this table. So sine theta, sine 0 will be 0, sine 30 1 by 2, sine 45 1 by root 2, sine 60 root 3 by 2, and sine 90 is 1, and so on. You can just start doing all this, and you can just remember this table. Okay, so now let us start to do some formulae. So let us say you have been given sine 40 and you are supposed to find cos 50 without the use of calculator, obviously. So how would you do that? Can you even do that? Yes, the answer is yes. So how do we do it? So we use a set of formulae called complementary angles formulae. So you would have studied in your lower classes that complementary angles are those which add up to 90 degrees, right? So we use this set of formulae which I am going to show now. So sine theta is cos 90 minus theta. So we have sine theta equal to cos 90 minus theta, and cos theta as sine 90 minus theta. So you just remember it like this. I mean, it's pretty symmetric. You can just remember it just as lit. And tan theta is cot 90 minus theta. And what will be the next? Yes, cot theta equal to tan 90 minus theta. And can you guess the next one? Okay, fine, I'll do it. So it's cosecant theta is secant 90 minus theta, and secant theta equal to cosecant 90 minus theta. So this is a box, this is a box, and this is a box. You just remember it, it will be very easy. This formula will simplify so many problems. It will just give you the answer just like that. Okay, so just remember this formula. It's not very difficult, it's just write it 2 or 3 times, you just remember it very easily. So now let us say you have been given sine 40. In the previous question, you have been given sine 40 and you were asked to find cos 50. Now here you have been given sine 40 and you're supposed to find cos 40. How would you do that? Now there are some identities through which we get to this process, but I'll just give you a brief proof of the identity. So given here is a triangle ABC right angled at B. So first identity, the first identity is, now let us first calculate the ratios. Sin theta equal to BC by AC, sin theta equal to BC by AC, and cos theta equal to AB by AC, right? So now what will be sin squared theta? Sin squared theta equal to BC squared by AC squared, and cos squared theta is equal to AB squared by AC squared. So now we add these two ratios. So what is sin squared theta plus cos squared theta? BC squared by AC squared plus AB squared by AC squared. Now by Pythagoras theorem we know BC squared plus AB squared equal to AC squared. So the numerator will be AC squared, denominator will be AC squared. So sin squared theta plus cos squared theta equal to 1. Now this is an important identity. This will be useful in many ways. And identity 2. Now for identity 2, you just divide this thing, this sin squared theta plus cos squared theta equal to 1 by cos squared theta on both sides. So what do you get? Sin squared theta by cos squared theta. What is sin by cos? Tan. So it is tan squared theta plus cos squared by cos squared is equal to 1, and 1 by cos squared theta. What is reciprocal of cos? It starts with a C. So it should be starting with an S. The reciprocal should start with a S. So it should be secant theta. So tan squared theta plus 1 equal to secant squared theta. Now this is the second important identity. Now the third identity is we divided by sin squared theta. So sin squared by sin squared equal to 1, and cos by sine is cot, which is cotangent. So cot 1 plus cot squared theta equal to 1 by sine squared. What is sine? Reciprocal of sine. It starts with an S. So S means the reciprocal should be with a C, which is cosecant. So 1 plus cot squared equal to cosecant squared. Now that's it. These three formula and your previous complementary angles formula will solve majority of your problems in this chapter. Okay, now so let us do some application and problems, and before we jump into applications, let us get some two or three terms familiar. So now figure on the right gives us a clear understanding of the terms. I'll explain it to you now. The angle between the line of sight and the horizontal is called angle of elevation. I'll explain it to you. See, now let us say you are standing over here and this is your eye. Assume this is an eye, and this object is an aeroplane. Let us say it's an aeroplane and you're seeing the aeroplane, and this line, this horizontal, is your horizontal eye level. Now imagine a line parallel to your eye. Okay, now there will be an angle which the aeroplane will form with your horizontal eye level. Now that angle is known as angle of elevation, alpha. Now the angle between line of sight and horizontal is called angle of depression. Now let us say you see the reflection of the aeroplane in the water. Now let us say there is water over here, and you see the reflection of a bird or an aeroplane in this water. So now you see the object inside there. So now the object is below your eye level. So again you draw a horizontal eye level line, imaginary line, and then the angle between the line of sight. The line of sight is the line between your eye and the object. Okay, so this line is imaginary line of sight. The angle between this object and your horizontal eye level is known as angle of depression. These two terms do not change this. Even in the questions they don't change this. So use these terms even while giving your solutions. So this will be beta. Stay tuned for problem solving, and thank you.